Hi everyone, it's Coach Fred here, and today I'm going to be going over practice test 3 math calculator number 34. All right, so we're given in a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by the central angle AOB is what fraction of the area of the circle? All right, so let's make sure we understand what's happening here. We have a circle, and we have this central angle. So a central angle is an angle formed by the center of the circle. So the center is the vertex. So we have this central angle here, which is 5 pi over 4 radians. Now, if you haven't learned about radians yet, this would be a little bit more challenging for you, but it's still something you might be able to do. But we want to make sure that we know that this is the area of a sector. It's like a piece of pizza. It's a proportional, it's a ratio of the entire circle's area. So if we know that the area of the whole circle, say, was, 500, then this would be a piece of that, so maybe 100. That's a fractional relationship. It's a proportional relationship. All right, so the fractional relationship relates to that central angle. That central angle is a piece of the entire rotation of a circle. So if it were in degrees, we would say the central angle over 360, that would tell me the proportional relation, the fractional relationship with the area, as well as the circumference. We call that arc length. So area of sector and arc length, they're both related to this idea of a fractional relationship or a ratio of the entire circle. All right, and what do I mean by that? Let me just give you an example. If I said to you that this was a right angle right here, and I told you that the area of the entire circle was 400. Well, if I asked you for the area of this piece of the circle, this area of the sector we call it, I hope you see that that would be 1/4 of the circle. Why? Well, because this is a 90-degree angle and it's a fourth of 360. Why? Well, because if you put 90 over 360, that's 1/4 of the whole circle. So that's what's happening here. Okay, so, but the problem is it's not in degrees, it's in radians. So the one thing that when you learn about radians is that another way to write, if I wanted to take 360 degrees and turn it into radians, we would say 2 pi radians. So 360 and 2 pi are the same thing, just a different type of measurement. So my central angle would be 5 pi over 4. So I would put 5 pi over 4 over 2 pi. All right, now there's a couple ways you could do this. I like to think of this as a simple fraction and this as a simple fraction, and so multiply by the lowest common denominator of each simple fraction, which would be 4, and I do 4 over 4. I'm allowed to multiply by that because it's the number 1, so it would cancel here, and that would give me 5 pi over 8 pi, which then the pi's would cancel and you'd get 5/8. Now, while I don't like to think of it like this, 5 pi over 4 divided by 2 pi, another way of, I know a lot of kids will say, oh, you just keep change flip because you learned that in pre-algebra. It's not really the best way to think about it because it's not really mathematical, but you can think about it like this. 5 pi over 4 divided by 2 pi over 1, it's the same thing as multiplying by 1 over 2 pi. So again, giving me 5 pi over 8 pi, or 5/8. All right, so that's my quick little video today on number 34 and area of sectors. And just remember that area of sectors as well as arc length of a circle is a proportional relationship with the area of the circle or the circumference of the circle, whichever the question's asking you about. All right, hopefully that was helpful. Have a great day.